This question is from GATE 2022 Mechanical Engineering paper, Set 1, question number 43. A solid spherical bead of lead, uniform density being 11,000 kg per meter cube, of diameter d equal to 0.1 mm, sinks with a constant velocity v in a large stagnant pool of a liquid, whose dynamic viscosity is 1.1 into 10 to the power minus 3 kg per meter per second. The coefficient of drag is given by CD equal to 24 by RE, where Reynolds number RE is defined on the basis of diameter of the bead. The drag force acting on the bead is expressed as D equal to CD into 0.5 times rho v square into pi d square by 4, where rho is the density of the liquid. Neglect the buoyancy force. Using G equal to 10 meter per second square, the velocity v is dash meter per second. Let's find this out. So we'll write the given things. Density of the bead, let that be rho b, 11,000 kg per meter cube. Diameter of this bead is given as 0.1 millimeter. So we can convert this to meter, 0.1 into 10 to the power minus 3 meter. Density of the liquid is not provided. We'll keep it as it is. Reynolds number is defined on the basis of diameter of the bead. So we can write the Reynolds number as, so Reynolds number is calculated using density of liquid, not taking the density of the material of bead. So it is rho L into V into diameter of the bead upon nu, which is dynamic viscosity of the liquid. Both rho and mu are properties of liquid here. Also, drag coefficient CD is given to be 24 upon RE. Let's substitute RE here. So we have 24 upon rho L V into D upon mu. This will be equal to, substituting the values that we know. So we have 24 into nu is given 1.1 into 10 to the power minus 3 kg per meter second. This is an SI unit. So we have substituted it as it is given, divided by rho L is not known, keep it as it is. V is not known, keep it as it is. Into D is known to us 0.1 millimeter. So we have converted it to meter, 0.1 into 10 to the power minus 3 meter. So this turns out to be 264 upon rho LV. Now it is given that we need to neglect the buoyancy force. So FB is equal to 0. If we draw a free body diagram of the bead, this is the bead in submerged, then weight of the bead is going to act downwards. We can write this as mass into gravitational acceleration G. Buoyancy force will be acting upwards, but that we have taken 0. So the only upward force here will be the drag force Ft. Terminal velocity of the bead will be downward, of course, because the bead is moving down because of its weight. So we now have, for this particular instant, we can use the equilibrium equation, summation Fy equal to 0. This gives us weight of the bead will be equal to the drag force on it. So we can write down weight is mass into gravitational acceleration. Mass can be written as density into volume into G is equal to, drag force is already given to us. Also we know the standard formula, that is half into CD into rho V square. This rho here is rho L into cross sectional area, that is pi by 4 d square. So we can substitute what we know. We know CD here, we know D here, and we also can calculate the volume of the spherical bead. We know rho B also. So let's substitute whatever we know and then simplify it to find out V. Rho B we know as 11,000 into volume can be written as 4 by 3 into pi into R cube. So it will be D by 2 whole cube into G is 10 meter per second square, which is equal to half into CD we found out as 264 upon rho L into V into rho L into V square into pi by 4 d square. So let's just divide the common terms out on the right hand side and left hand side. Pi and pi can be divided. Rho L upon rho L will be 1. D square upon V will be V. Then d square here and d cube from here. Don't forget to write cube here so that we don't miss out taking the cube of denominator. So d cube here will be only giving us d. So yeah, we have cancelled out all the common terms. And therefore now we are left with V will be equal to. So we'll write the remaining terms here. We have 11,000 into this 4 by 2 cube is nothing but 4 by 8, which is 1 by 2. So we'll divide this with 2 here into this 3 in the denominator remains. We can substitute value of d, which is 0.1 into 10 to the power minus 3 into 10. And then from the right hand side, we have the coefficient of v as 264 upon 2, which is 132, 132 upon 4, which is 33. So simplifying this, we will have 0.1 into 10 gives us 1. 10 to the power 3 from here can be multiplied to this 10 to the power minus 3 will also give us 1. So finally we are left with 11 upon 2 3s are 6 into 33. I kept it like this because we can reduce this fraction 11 by 33 as 1 by 3. So this gives us terminal velocities 1 by 18 meter per second. Let's go back and mark this option. We have the answer as 1 by 18 in option C. So option C is correct. To learn more about lift and drag forces, you can refer to the NPTEL video, lecture 46, Applications of Lift and Drag Force. It is from the course Advanced Fluid Mechanics. The course is taught by Professor Suman Chakravarti. He is from IIT Kharagpur. I hope this solution helps you clear your doubt. Thank you.